Okay, next we have Aurelien Degremont. He's an HPC system engineer at CEA, French Atomic Energy Commission. He's been there for 6 years. He's working on research and development for CEA supercomputers. He's been involved in the SHINE project as well as Lustre HSM. And that's what he's going to talk about today.
Thank you. Is it okay? Yeah. Is it better? Okay. So this presentation is more or less an update on Lustre HSM Binding project to give you the latest information we have around it regarding the different events that happen in the Lustre community and around the Lustre version. So I will go quickly on the project history. After that, a presentation of the components, how this works for those who don't know yet, or to have maybe a better view and remove some mistakes that are commonly made around this project. And at the end, a very early performance result. So this is, I will explain, and a bit information about how we would like to integrate this code. So about history, so this project began with CFS at that time. So at CEA we were working with HSM and Lustre in front of it for a long time now, and we have our own tool but with some side effects, so we have the idea of putting this in Lustre for a long time. So in 2007 we start working on this with CFS. It was a very specific times because we were speaking about architecture design for a while, for a long time. It was really difficult to go to something very settled and precise. So we were doing this with CFS people, and it was not the best time for this project. Hopefully, after a while, we start to have something around that, and in the meantime, the CFS was bought by Sun, and we start working more precisely on this with Sun people, doing more precise design around this project, and not big picture like architecture. So it was at this period that we started learning the Lustre internal. It was one of the most difficult aspects. I will talk about that later in another slide. That learning Lustre internal is one of the key aspects of this kind of project. So as it's quite long, we arrive at after that Sun was bought by Oracle, and we arrived in the Oracle times. So last year was a bit special. So we were in the coding time at that time for this project, and we've got our exchange with Oracle. That was they wanted to have this code landed into the new Lustre 2.0 to what should have been 2.1 branch. And so we had hard pressure to have this able for the deadline. So we slightly changed the way we work for that. And fortunately, it happens what you know about Oracle. So all things around that was stopped and dropped. And so the landing never really happened. Only few patches were there. So there was a bit of between 2010 and 2011. There was a bit of period a bit difficult because we had not a lot of contact with technical people. And nowadays, hopefully, things are changing. We are working with OneCloud now to have this integrated. So now, in the meantime, we still keep on working on the project. So now we are rather in the debugging phase of the project. More or less all the features are there. And so we are working on debugging, testing, and do improvements around that. So I will go about the features and the detail of the project. So the idea of the project, for those who don't know, is to have Lustre acting as a cache in front of an HSM. So you can have all the advantages of the performance of Lustre and the capacity of your HSM, and it helps a lot to have the two components together, because you can we will migrate data between both components, and so this helps to have a lot of different features like space balancing, kind of file system backups, kind of extending space for your file systems. You can move the data in the HSM, and so you have more free space in Lustre depending on what you want to do. We will have policy management regulating all those migration. You can import Lustre file system based of what you have in your HSM. So it is important for disaster recovery cases. And to do so, we are added several new components to Lustre architecture. So the coordinator, which is the MDS component, the archiving tool, which is the glue between Lustre and the HSM's user space tool, and policy engine. We will deal with all the policy aspects. So I will cover this more deeply. So here is the first picture of how data will be archived. So when we say archive, we will replicate Lustre files data in the HSM. So to do so, we'll have requests sent to the MDS, sent to the coordinator through the MDS, which will dispatch the different requests, the different load on specific Lustre clients. So those clients are more or less standard Lustre clients, which are running a specific user space tool, which is the Copytool. Which will read the data from the file system, so you have the same kind of bandwidth and capacities and a standard process on Lustre file systems, and we'll copy this in the HSM. Yes. So, second point, when we have back the data up in your HSM, what is important now is to be able to apply policies for this. So the policies will be applied by the policy engine, which is a user space component running on a client. It uses a client API to access Lustre file systems and monitors it. And so it will send various requests to Lustre file system components to either archive or release data from Lustre file systems. As I said, there is a component, the Copytool, which is responsible for copying data from Lustre to your HSM. So this component is the only component that needs to know how to talk to your HSM, so which needs to know how use HSM API and things like that. So it is the only component that is HSM specific. Everything else is independent from the HSM, so it's easy to port this project to different HSM backends. So we have developed one for HPSS, which we call HPSS 7.3 at least, and will be available to all HPSS sites due to HPSS licensing concerns. There is a POSIX Copytool who able to copy from Lustre to any backends that support a POSIX API. So it could be anything, like if you can even think of copying through an FS server to something else, to copy to another Lustre file systems, to any HSM that support a POSIX API. And so this supports SAMQFS from Sun. We are working with AGI for DMF support, and there will be also things down around Enster by Fermilab. So the policy engine, it's a component which is a user space tool. It could be any component which is using the required API by the project. We implement one of these components, which is Robin Hood, but in fact, you can re-implement another policy engine if you want. The purpose here is if you have an HSM, normally an HSM has already its own policy engine to migrate this data internally between the different levels of the HSM. So it could be possible that if we extend the HSM policy engine to access the Lustre API to do the same kind of job than Robin Hood. But currently this does not exist, so only Robin Hood is there. So Robin Hood has a lot of features. At first it is still a program due to do file system monitoring. So I often receive emails about people speaking about Robin Hood as a Lustre HSM project. So to be clear, Robin Hood is a part of the project, but not the project. So do not go to the Robin Hood website to have the Lustre HSM project. It's not there. It's only a component. For that, this is something that often go. And Robin Hood is not only there for Lustre HSM. There is a lot of feature. It can work in a lot of different cases. The more current one is to manage scratch file systems, to apply policies and remove files depending on criteria. You have very nice policies and criteria for that. And he is also used now for file system statistics. There is several sites that are using it to have more information about how their users are using the file systems, and you can do very precise criteria like path size or etc. Something more precise than just quotas, by example. And he has also everything which is needed for Lustre HSM, because it's more or less the same kind of needs, and we use all the policy available for Robin Hood. So the coordinator component, so it will be a new thread which will be on the MDT. So his purpose is to centralize the HSM request to avoid duplicate requests and dispatch the different requests on the available agents. So he's there to control the load and on the agent, and he has his log to save all the different requests that are needed and to replace them if there is some kind of crash. I will give you a bit of more information about coordinator at the end regarding performances. When I spoke about file releasing, about removing data from Lustre files, here is a bit more detail about that. So the project adds a new command to LFS, which gives you the different new state of one file in Lustre. So you can see in this example that the file was archived. That means that there is a copy in the HSM backend, and that the file is not dirty, so it's a good candidate to be released. That means that data will be purged. So there is also new state, so archive the file as a copy in the backend. Dirty means that the file as a copy, but there is something more up-to-date in Lustre, so we need to do another copy to replace the obsolete one in the backend. And if the file is tagged as release, this means that the data have been removed. And in this case, we see that the file size is correct. We have the same file size. So when you browse the metadata, you browse your namespace, you see normal files with normal size. But you can see that these files use 0 blocks now. So it don't consume any space on the file system. So I will show you very early performance result. This is not intended to be final results. It's just a rough idea of what we can do now with a very simple configuration. Just to give you some hint, a bit of idea, I'm really confident to improve this. About the test bed, it is more a development platform, so it's something really simple. That's why I say when if you put real hardware, you will have better results. So in this case, it was a few virtual machines on 2 Dell R710 with Xeon processors. So very simple configuration, simple file systems, no very expensive hardware for that. So very small test bed. About the performance, one aspect of this project introduced a new kind of lock, which is the layout lock. We expect it to have very low RPC overhead, so very low performance impact on the file system in kind of standard use. And this project also uses a lot the MDT changelog, so the new feature in Lustre 2.0. And currently we have seen low impact on MDT performance, but we have not tested it yet with the MDT very loaded with a high rate of metadata requests on it. So first information about release. So release is synchronous data purge, so we remove the OST object synchronously. This is normally runs by the policy engine. So policy engine will do this in background. So that's why the synchronous aspect is not really an issue. And on this very simple platform, we achieve a rate around 120 release per second, whatever more or less the number of files we were releasing. So I think for the moment it's not really a problem there. And the second numbers, it's about archiving. So in this case, we were more or less benchmarking the coordinator. We wanted to avoid to bench the platform and the OST performances and these kind of things, and the disk backend and things like that. So we were creating very small files. It were 4K files. What was interesting there is the number of requests we can handle with the very simple test platform. So we were around 400 file handled per second, which means more than 1 million archives per hour, which is much more than what current HSM can achieve. In fact, if you've got this kind of requests, your bottleneck will be your HSM and not Lustre. And I'm really confident to improve those numbers. There is different aspects that could be greatly improved in the current prototype, so I'm not afraid by that. And with other hardware, I think you can have better things. A few information about Lustre. So as I said in the beginning about this project, in fact, what is really difficult there, it's not really to to improve to code this. What is difficult is to learn Lustre, to have all the needed information about the Lustre code to do the right code. When you know exactly how things work, it's not really difficult to do the code. Especially what was difficult for Lustre HSM is that this project, which is not really a big project in terms of line of code, but it impacts a lot of different Lustre parts. So if we split the project in different, more or less, patches, the different parts of the project, I've shown here the different pieces of Lustre that we had to learn. So over the infrastructure, we had to learn how to write new RPCs, layout lock and group lock. So we had to learn all the different aspects of the Lustre LDLM locking. The new CLIO in Lustre 2.0 was concerned also by that. So we had to learn how this works. The release part is not really a big patch, but is dealing with a lot of different aspects of Lustre. So the locking, the client I/O, how OST objects are handled. This code is in MDT, so it implies a lot of MDT layers. And also the coordinator was using the Lustre log mechanism. So it is a lot of different parts of the Lustre code that we need to learn. So I think this is something really important for this kind of project, which I think should be different for other patches, that we are very touching a lot of different Lustre aspects. So about the integration, so as I said, there were some effort done to land code in Oracle 2.1 branch, which will never exist. So there is still the Git there. We learned some patches, but everything was stopped due to Oracle changes for that. So now we are working with OneCloud on that. We would have been interested to land some patch in the 2.1 release, but we understand that the current concern is to release a new version of Lustre quickly, something which is stable. So the target is now only to stabilize the code and release it quickly. So no new features for that. So regarding the discussion I had with OneCloud in those days, I think we will start again to land some patches in the 2.2 branch when this will be available in the following month, I think. So I cannot give you the details. We have to work on that still with OneCloud and have several steps to have everything there. So I cannot tell you now when this will be available and when everything of this will be finished. I've learned regarding the previous years that this kind of project can be delayed by a lot of things, and it's really tricky to handle all these aspects. So I can only tell you what we plan to do, and hopefully things will be done nicely in the following months and until the end of this year. Thank you. Do you have questions?